Unit 5, Day 2, Part 2, Take 2, actually. Take 1 will never be seen by anyone again. Today's October 9th, so if you're watching at home trying to remember where we are or what you missed, we're on the very last page of the Day 2 notes is where we are. Function analysis, that's tomorrow's stuff. Concavity, points of inflection, that's not us. So 1 page prior to that, we'll do 3 examples, and then maybe we'll have time to work some of the worksheet together. Okay, find all relative extrema, so that means maximums and mins, for that function, and designate each as a relative maximum or a relative minimum. Okay, so don't just say here's the extrema, like tell us which one it is. Okay, well, I know maximums and minimums happen when f prime changes positive to negative or negative to positive. So let's find f prime, and then kind of go from there and see where we land. So 4x cubed minus 32. Let's see. So I want to know where that's 0. Because critical points, you know what, let's back up. Let's think big picture here. Critical points tell us the potential max and min. And then we'll put those on a number line with the first derivative. And then use the first derivative test to identify maximums and minimums. Yeah. Think big picture for a second. I jumped right in and did a derivative. I should have slowed down here. Critical points tell us the potential maximums and minimums. So we'll find those first. We'll put those on a number line, and then the number line will help us figure out if it's actually a max or a min, or maybe neither one. Maybe it stays increasing. Okay, critical points where f prime is 0 are undefined. Let's see, factor out of 4. So either 4 equals 0, that doesn't happen, or x cubed minus 8 equals 0, so x equals 2. So my critical point is x equals 2. I don't know if that's a max or a min or neither, but it's a critical point. It didn't specifically ask me for a critical point, but I've got to find that along the way to getting extrema. So let's make a number line with 2 on there, because I want to see where this thing is increasing or decreasing. So let's check 0 and 3 into f prime, because f prime will tell us increasing or decreasing. So 4 times 0 cubed minus 32 is negative. And if f prime is negative, what does that tell me about f? F is decreasing. A picture may be overkill, but maybe it's helpful. So f is decreasing. I don't know what it looks like, so just a rough sketch will help me visualize. I can guess what's going to happen. It looks like it's going to be a minimum, but I don't really know that until I know that this side is increasing. Because if it's decreasing, then it's neither one. So let's check 3. 4 times 3 cubed minus 32. Well, I don't need to be exact here. 3 cubed is 27. Times 4 is bigger than 32. So I don't really care about the exact number. That's going to be positive. And if f prime is positive, that means f is increasing. Again, the picture maybe helps. If I'm changing from decreasing to increasing, what's going on at x equals 2? So we say x equals 2 is a relative minimum. That's not quite enough because justify your answer. So how did I know that x equals 2 is the minimum? Because f prime changed from negative to positive. Again, the picture and the kind of the table setup, like all that's helpful, but that's not enough to justify your answer. You need to specifically say f prime changes negative to positive. Number 2, find all values of x, if any, at which y equals x plus 2 sine x has a local max or local minimum on 0 to 2 pi. Okay, that's nice. So I can only look 0 to 2 pi. Classify each as a max or min and justify your answer. Okay, so kind of the same thing that we just did. Critical points leads to a number line with the first derivative. And once we do that, we can, you know what, I'll just say with f prime. So I don't need to put all that to the side, but that's just like my brain thinking through what's the process for this problem. Critical points will give me the potential maximums and minimums. I'll put those on a number line, check f prime, and then I'll be able to know what's going on in terms of increasing and decreasing. Okay, so first thing is y prime equals, let's see, the derivative of x plus 2 sine x. Let's pick on some people. Grenier, we'll let you have both of them there. What's the derivative of x plus 2 sine x?
1 plus 2 cosine derivative.
Okay, you're trying to do chain rule, which I like, but you keep the argument the same. So 2 cosine of x, and then what's the derivative of x? 1. So times 1, but that doesn't really do anything for us. Okay, critical points are where y prime is 0 or undefined. It's not undefined anywhere because cosine is continuous. We're not worried about that. So let's set it equal to 0. So cosine of x equals negative 1/2. Uh-oh, someone's going to get a unit circle question. Bryce, I'll try to walk us through the answer here. Kylie, you'll be up next, so you start thinking unit circle over there. Bryce, what quadrants have a negative cosine? Narrow it down for us. Where am I looking? The second and third. Good. So second and third have a negative cosine because it's on the left. Cosine is the x value, so it's over there on the left. So Kylie, be more specific. What's the either what's the angle or what's the reference angle or what's the denominator for where cosine is 1/2? Is it the over 3s, the over 4s, or the over 6s?
It's pi over 3.
Yes, it's the over 3s. So we'll turn this into an even longer question. So Brandon, what's the over 3 angle in the second quadrant? Like I know it's something over 3, but what's this angle? I know it's over 3. It's the steep angle. Pi over 3 would be in the first quadrant. You're the best. You can sit on my desk. 2 pi over 3 is the over 3 angle in the second quadrant. Ian, how about the over 3 angle in the third quadrant? 4 pi over 3. Okay, so all of that worked, and that was like step 1. I got my critical points. 2 pi over 3 and 4 pi over 3. So those are the potential maximums and minimums. I don't know if they're maximums or minimums yet, because I need to do the rest of this problem, put them on a number line, and test f prime. So 2 pi over 3 and 4 pi over 3. On the interval 0 to 2 pi, it includes 0 and 2 pi, so I can test 0. I was trying to see if I can test 0 as one of my test values, and I can. How about something between 2 pi over 3 and 4 pi over 3? Pi. And how about something bigger than 4 pi over 3? 2 pi. Or if you're feeling adventurous, none of those were double roots, so pretty sure that we could use the alternating rule here. What's that? You don't want to do that? You probably don't want to do that. You probably want to test them all to make sure. But if you're in a bind or you're feeling pressure for time or whatever, it's like, well, let me test one and hope that the alternating rule works. But the best bet would be check them all. Okay, so f prime, because f prime will tell me if f is increasing or decreasing, and then I'll know if I have a max or a min. So if I plug in 0, and again I'm plugging it into the prime, not the original, because I want to know if f is increasing or decreasing. So 1 plus 2 cosine of 0. Cosine of 0. What's the cosine of 0? 1. So 1 plus 2 is 3. That's positive. So that tells me that f is increasing. So f is increasing. I plug in pi. 1 plus 2 cosine of pi. Let's see, cosine of pi, well, there's a unit circle to look at if it helps, is negative 1. So 1 minus 2 is negative. That means f is decreasing. The alternating rule is working, but let's keep rolling to make sure. 1 plus 2 cosine 2 pi. Well, 2 pi is the same as 0, so cosine of 0 is 1. 1 plus 2 is positive. So f is increasing. So now I can look at my picture and it's pretty easy to see where the maximums and minimums are. By the way, as usual, I'm showing a little more work than is absolutely necessary. What I have to see is this. Actually, you wouldn't. The number line is tricky. You don't have to show the number line, but you would have to show the 2 pi over 3 and 4 pi over 3. Now, I like showing all of it because it helps me get a real good sense of what's going on here. But if you did not want to show the arrows, and if you did not want to show the conclusion, you could still get there, right? Because you know f prime positive, you know what that means. F prime negative, you know what that means. I'm just writing it out to help my brain process kind of what's going on. So, green box must show. Outside the green box, maybe helpful, maybe not. So what's going on at 2 pi over 3? Is a relative maximum. Because, what's my reasoning? How do you know that 2 pi over 3 is a relative maximum? Exactly, because f prime changes positive to negative. And then same type answer for 4 pi over 3. X equals 4 pi over 3 is a relative minimum. Again, I'm just looking at my picture. But I can't just say because my picture says so. It's like I got to use some calculus stuff here. F prime changes negative to positive. So that justify my answer. That's f prime changing one way or the other. Number 3. Which of the following is true if f equals that ugly thing between 0 and 2 pi? Okay. And so this is just like how many mins and maxes does it have. So I've got to do the same stuff I've been doing on the others. I just, instead of writing it all out, like formally, once I get to my picture, I'll be able to know how many maxes and mins I have. So I need critical numbers to set up a number line. And the number line will help me with f prime. And then I can probably answer the question from there. Again, it won't be a formal type answer, but especially if I draw the picture, I'll be able to see how many maximums and minimums I have. Ooh, e to the x over cosine x. That looks like quotient rule about to happen here. So I need the derivative of the top and the derivative of the bottom. Mia, what's the derivative of e to the x? No, but it is one of the sort of tricky, easy ones, so you're sort of on the right path. Help her out, somebody. What's the derivative of e to the x? It's just e to the x. And then the chain rule would be times the derivative of the exponent, but that would just be 1. Rabia, how about the derivative of cosine? Negative sine of x. Okay, so put them together. Let's see. gf prime minus fg prime over g squared. There's still a few people getting that backwards. People not putting their gf first. It's going to mess things up, again, in relationships and in quotient rules. gf's got to come first. gf prime, so that would be e to the x cosine x, minus fg prime, so e to the x times negative, so I'm going to just make this a plus, e to the x sine x, all over g squared. Let's see, trying to make my life a little easier here. I'm going to factor out e to the x. So that leaves cosine x plus sine of x over cosine of x squared. Let's see. Okay, that's going to help me find critical points. Critical numbers are where f prime is 0 or f prime is undefined. Oh, and we will have an f prime undefined because where cosine is 0, that's going to be a problem. So let's do the 0 part first, and then we'll do the undefined part. So 0 would be where the numerator is 0. Cosine of x plus sine of x equals 0. We've done one like that before. There's a couple ways to handle that. I think I would just move one of them over. So I'm trying to think where cosine and sine are like the same value but off by a plus or minus. So where does that happen? What angle has the same cosine and sine except for their positive negative thing? So it's definitely the over 4s, right? Because that's root 2 over 2. So I know it's something over 4. So what quadrants have a different, careful to use the word sine, because a different positive or negative for cosine and sine? Fourth, yes. In the third, they're both negative. So second and fourth. So 3 pi over 4 and 7 pi over 4. f prime undefined, that would be where the bottom is equal to 0. So cosine is 0. There and there. Like, I'm more of a visual person first. Cosine is 0 there and there. There being pi over 2 and 3 pi over 2. So, lovely number line I've got going here. Got to put all those on there, preferably in the right places, right? Maybe it helps to see them on the circle. I don't know. So pi over 2, 3 pi over 4, 3 pi over 2, and 7 pi over 4. I'm real hesitant about using the alternating rule if I was inclined to do so, because this bottom was squared, so that looks like a double root. So I'm hesitant about pi over 2 and 3 pi over 2. Alright, almost out of space. Let's plug in 0, and I'm just going to check and see what f prime is. So I'm not going to do the arrows and say that f is increasing. I'm just going to go find f prime, and that'll be good enough. So if I plug in 0, let's see, e to 0 is 1, cosine of 0 is 1, sine of 0 is 0, so all of that is positive. Something between pi over 2 and 3 pi over 4. Oh man, that's like right in there. That's like 2 pi over 3. Well, again, I'm only concerned about positives and negatives, so I don't think this is going to be too bad. E to the x, you know what? That's always positive. So I can stop worrying about that, right? That's always going to be positive, so it doesn't matter what I plug in there. Cosine of 2 pi over 3 is negative. Sine of it's positive, but the sine of it's more positive than it is negative. So that one's going to be positive. And so I was right, that double root doesn't change. I'm short on time, so I'm going to trust the alternating rule. That one's going to be negative. It's not going to change across 3 pi over 2, so that one's going to be negative. And 2 pi, I should get the same thing as 0, so that one should be positive. So that's a little bit of a check on my alternating rule. So I've got positive, positive, negative, so there's a max, and then there's a min. So 1 max and 1 min. Part B, answer B. Because negative, negative, that just means it kept going down. Positive, positive, it kept going up. I was looking for changes in signs. Alright, so try worksheet number 2. I'll see you on next time I see you.